Hi everyone, my name is Ihani. I'm gonna do the question 10 of homework 8, so let's begin. Okay, so it wants us to prove that if xt is a normal so if the normal process is wide sense stationary, which is WSS, then it is a strict sense stationary, which is SSS. So actually what we want to prove exactly is that this for fx x1 to xn and t1 to tn can be written as a fx x1 to xn and t1 plus epsilon until the tn plus epsilon for any n, any t1 t2 to tn and any epsilon. Because we know that if it is a SSS, then the xt and xt plus epsilon can have the same statistics for any epsilon. So this is what we actually want to prove, which means if we prove this, we can prove the what it wants us to prove. So, and we know it is xt is a normal, so we have this equation like fx x1 to xn t1 to tn equals to this format. It's the definition of the normal process, and here this eta equals to the expectation of xt, which is the which is a constant, and here the c represents for the autocovariance matrix, and by the definition here the c equals to the expectation of x minus eta times the transpose of x minus eta, and we can just expand it. So here x minus eta can be written as a matrix from the xt1 minus eta to to the xtn minus eta, and the transpose can be written as a xt1 minus eta to xtn minus eta. It's just a transpose format. And here we want to calculate for each term if we expand it. So here, like if the expectation of xti minus eta times the xtg minus eta, then we know we expand it, so the first term will be the expectation of xti times the xtg side, so this is actually the rtitg, and this minus eta times minus eta can be like plus eta square, and here we have minus eta times this expectation of xti, and actually this expectation of xti also equals to eta because it's a WSS, so the expectation is constant eta, and here we also have a expectation of xitg minus eta times minus eta, and it's also eta, so this whole thing is actually minus 2 times eta square, and so the final result will be the rtitg minus eta square. So back to this equation, so this matrix, the multiplication of matrix, we multiply each term of it, so we will get rt1t1 minus eta square, and here is rt1 tn minus eta square, and to the last row will be rtn t1 minus eta square, and here is rtn tn minus eta square. Of course it can be written reversely, so, and it is equals to the r0 minus eta square, and here is rt1 minus tn minus at eta square, and the last row will be rt1 minus tn minus eta square, and the last will be rtn minus tn minus eta square because it's WSS, so we will get this format. And we now know that it actually can be determined by each pair of ti minus tg for I doesn't equal to g. ig can be 1 to 2 to n. So which means that this format initially this fx x1 to xn, t1 to tn can be rewritten as a fx x1 to xn, and here the t1 to tn can be written as a ti minus tg for each pair of ig where I doesn't equal to g. So we know that if x1 to xn and t1 plus epsilon to tn plus epsilon can be written as fx x1 to xn, and here is can be written as ti plus epsilon minus tg plus epsilon, and we can eliminate the epsilon for each pair of ig where I doesn't equal to g, so it will equal to fx x1 to xn ti minus tg for each pair of ig when I doesn't equal to g, and here it can be written as fx x1 to xn, and here's t1 to tn. So that is true for any n and any t1 to tn and any epsilon. So now we get what we want to prove, and then therefore we get the final result that if xt is normal and WSS, then xt is SSS. So that's all for the question 10. Thank you.